Have you ever wondered how computers understand maps? When you open Google Maps or analyze satellite images in GIS, the computer isn't just seeing pictures. It's reading data. And almost every map in the world is built using two powerful data models, raster and vector. If you're learning GIS, remote sensing, or spatial analysis, understanding these two models is absolutely essential. So, in the next few minutes, I'll show you what raster data is, what vector data is, and when you should use each one. Let's start with raster data. At first glance, this looks like a smooth, colorful map of southern Africa. But what you're actually looking at is a grid made of millions of tiny squares called pixels. Each pixel stores a single value. For example, elevation, temperature, rainfall, vegetation. This type of information is called continuous data. That means every location on the map has a value. The low coastal areas have lower elevation values, while the mountains of Lesotho have higher elevation values. Now watch what happens when we zoom in. The smooth map starts breaking apart. And we can now see the individual pixels. Each one is a cell with a single value. The size of these pixels determines the spatial resolution. Smaller pixels mean higher resolution and more detail. Larger pixels mean lower resolution and less detail. This is why satellite imagery and elevation models are usually stored as raster data. Now let's look at the second major data model, vector. Unlike raster, vector data represents discrete objects. Instead of pixels, vector data uses geometric shapes defined by coordinates. There are three main vector types: points, lines, and polygons. Points represent specific locations, like hospitals or schools. Lines represent linear features, such as roads or rivers. Polygons represent areas, like provinces or land parcels. Now let's zoom into this boundary line. Notice something interesting. The line stays perfectly smooth and sharp. It does not break into pixels. That's because vector data is mathematically defined using coordinates. So, no matter how far you zoom in, the line between point A and point B remains precise. But the real power of vector data lies in its database connection. Every point, line, or polygon is linked to attributes. This means we can ask questions like, which province has the largest area? How many schools are in Gauteng? Which road is the longest? This ability to connect geometry with information makes vector data extremely powerful for spatial analysis. So, when should you use raster, and when should you use vector? Use raster when working with continuous data like satellite imagery, temperature, rainfall, and elevation. Use vector when working with discrete objects like roads, buildings, boundaries, and infrastructure. Both models are essential tools in GIS. And most spatial analyses actually combine both raster and vector data. So now you know the difference between raster and vector. These two models are the foundation of modern GIS, remote sensing, and spatial analysis. If you're starting your journey in geospatial science, mastering these concepts will make everything else much easier. And in the next video, we'll explore another powerful concept in GIS. Until then, keep exploring the world through data.